Hello all, welcome to another video session. In the last video, we talked about the orange man's house, where we programmed him going into this house, his door, the lighting, and we introduced an on delay timer, which we use for the light relay. In this video, I'll be talking about quite a lot of things. One, I'll be talking about a TOF timer. I'll also be showing you some best programmings on how to use timers. I would also show you the process, which now we would complete with closing the door using a timer as well. So one of the first things that you would notice is that we now have some proper names on our tags. Earlier we had things like S1, S2, um, and the likes. However, now we have auto, out sensor, in sensor, door relays, light relay. One of the best things, like I've always said in your programming, is to always ensure that you have proper tags, proper namings to your program. So, what do we want to do today? What I want to do now is to introduce an off timer. You know how on delay timer works, which is when you trigger the input, it counts, and then after the timing is elapsed, which is what you input on your PT, here it's hard coded T 5 seconds. When this timing is elapsed, then you switch on the output of the relay. Let me show you on the PLC sim just to refresh our memory on that, and then we can go into what we want to do today. So first I'll just put this on, it's on auto. We need our in sensor. So I'll just click on the in sensor, indoor sensor. I'll put this on. We have the auto on. I'll just put the indoor sensor. So now we have the indoor sensor. This is counting. It would count up to 5 seconds, and then we have the output light relay, which is what we want. I'll take this sensor off now, and then we'll see what happens to this relay. So I take this off. Immediately I take it off, it goes off, which also defeats the purpose, right? Because what we want to do, it means that once the orange man leaves this light, this sensor, the light goes off. Even though the light comes on after 5 seconds, the light goes off, which is not what we want. So what do we do? Instead of just a call, we'll put this as a set. So when you put this as a set, it stays. The light should stay on. I'll download this, we'll test it, and then we'll move on to the off timer delay. Of course, we have to download, it's a consistent download. So right now, I'll go online again. Yes, we're online. The auto switch is on. I'll just go straight to the indoor sensor. We have the indoor sensor switch now. The timer will count to 5 seconds, which is what we set here. The light is on, and then I can take off this indoor sensor switch, right? So I take it off. But you can still see that the coil is on, which is what it's supposed to be. When the orange man leaves the sensor, the light should stay on. Something else should trigger it to go off. We're not doing that today. So what we want to program now is the door. Currently we have the door. Immediately the indoor sensor sees the man, the orange man. Immediately he gets on the sensor, the door closes. However, we want to put a delay just in any case that he is not completely inside the apartment and the sensor sees him. So we want to add a delay to that. So how do we do that? Basically, I put another network. Let me go off. I'm going offline so that the programming can be smooth and fast and we're not programming while it's online. I'll use this line to add another branch. See, to add another open branch. This is open branch, this is closed branch. So right here, I want to add another branch in the same logic. I can also program this in another network if I want, but I want to add it in this logic so that we just have everything in one line. So why is this not working? Yes, now it's there. So what do we want to do? We want to reset the door, right? So I'll just bring this coil here. Yes, we want to reset this door. However, this is only connected to the auto line now. So if whenever we switch this to auto, it automatically resets the door, which defeats the purpose. What do we actually want to do? We want this door to reset after a certain timer has elapsed, right? So we need an off delay timer. So in this case, we can also use an on delay timer to reset this relay, right? We can also use an on delay, but I want to explain the concept of off relay so that we can have both of them in this network. I'll add another branch as well. I'll move, first let me introduce the timer. So we go to the timer, we go to off delay timer, T off. I'll add the T off. I'll just drag it on the network. Automatically it would create a DB, so you can put door off delay. So this is created by the system. It will go into the program resources. So we have a DB for the lights timer. We have a DB for the door off delay timer. Probably we need to change this naming as well. But let's just leave it because eventually we'll change everything. So what do we want to do here? I want to add code. We want it to the door to close after 10 seconds. T-10s. So we use 5 seconds for the light, we use 10 seconds for the door, right? And this output would come open. So, but we want this to also be on this line. So I'll move this here, and then I can branch this off. So I'll put this back here. I want everything to be on the inline sensor, and then I'll move this here. Then we can delete this line because we're no longer using it. So what do we have here? Everything is connected to the auto switch because everything depends on the auto switch. When the auto is on, our outside sensor is on, the door is open. When we come in, the outside sensor goes off, the indoor sensor sees orange man, it starts this timer, which is 10 seconds. It also starts this timer for the lights, 5 seconds. This timer would switch first, which is after 5 seconds, the light would come on. After 10 seconds, the door should go off. But we have not yet linked our door to this relay yet. We haven't done that. We can take just this output and put it on our door relay, right? I don't want to do this on the same network line because the Siemens timer has some internal errors, which I don't want to put this reset on the same line. So that's why I'm putting this on another line, but in the same network. So how do we do that? We can directly put the output of this timer on this line. So when this timer output is open, is on, then the door relay switch is on. However, I want to also show you something, another block, which is a comparator block, right? So there is a comparator block which you can use to compare equal to, you can compare less or greater than, you can compare equal or greater than, less or equal to, greater than, less than. Basically, what I want to compare in this case is equal to. So when this timer, the output of this timer, the timing elapsed, this ET, which I can pick from this door off relay. This is door off relay DB. When you click on it, on this view, you can already see the tags that you have inside. So I want to pick this ET, the data type is time. I want to compare it. When this time elapsed to 10 seconds, so it means I have to compare it as again to with another tag. I can directly code this in here, which I know is currently set to 10 seconds. So when this output is set to 10 seconds, then I want to close this relay. I want to reset this relay. Let's try this if it works. So I'll compile the block, I'll download this. We'll load it in the program, and then we go on. I'll also go to my simulation table. I'll put it on. It's taking quite some time, so the simulation table is here. It's currently off. Now I can put it on. Okay, first let me download the program to the simulation table. Yes, download. Good. So it's on the simulation table. It's on our simulation. Now we need to put this on. Our simulation is on now. I'll just switch everything off, right? Finish. We'll go online. Yes, so we're at the state where we want to be right now. I'll put this on this side. Where can you see this actually? Okay, here. So I'll click on auto. We have our auto on, right? We want to switch on our outdoor sensor. Our outdoor sensor is on, which then triggers the door relay to set. Orange man goes into the house. We'll switch off the outdoor sensor because now the outdoor sensor cannot see orange man anymore. Orange man is already inside the apartment. This is taking quite some time. Okay, I have to reset this again. It went off. Okay, so the light is on. Orange man, the outdoor sensor is off. Fine. The light is still the door is still set on because we use a set. That's fine. Now the indoor sensor sees orange man and immediately it starts counting 5 seconds in this case because this is the on delay. So the on delay starts immediately the trigger is set and then the light is on, right? The light relay is on. However, you can see that the off delay timer has not started yet. I hope you can see this. Let me increase this a little and minimize this. Yes, so you can see the off delay timer hasn't started yet. Let me also go online with the DB itself so that you can see this is the DB of the block. You can already see everything also happening in there. Yes. So right now, the off delay timer is still off. It hasn't started yet. Now we want to start it. How do you start the off delay timer? By switching off the input that goes in the in contact of the block. So what I will do now is to switch the indoor off. So orange man walks away from the indoor sensor. He walks away from it and then the timer starts. And you can see our comparison is also working. The timer will count from 0 to whatever we set 10. Now that we've set it to 10, you can see then it switches on the relay, the door relay, it resets it. So now we have the door is off, is closed. So it means when orange man walks away from this sensor, the off delay timer for the door then starts to count up to 10 and then closes the door, which is exactly what we want. So 10 seconds after this, it closes the door, right? So this is what we want. However, in our program, we have quite a lot of jargons and repeated things, which is also what I want to show you in this video. One of it is having so many timer DBs, different DBs. These are global DBs that have been created by the system. However, we have a function block, and we can also make use of our static part of our function block because it has a DB. So what can we do? We can create a door of delay timer. So the data type is time, right? Time. And we can use this DB. It will create the same structure that this DB has. Same structure. Let's go offline. So everything goes smooth. Because now we're changing the interface of the function block, the DB itself. So we've created this. Instead of time directly, because this is time directly, it's a T on. So you can just click on the drop down. It should give you the data type so that you're picking the correct thing. It's a T on data type. Am I correct? Yeah. T on. So the 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 proper way is T on underscore time. Correct. And you can see the structure. So the structure is exactly the same structure which you have in this global DB. The PT, the ET, in, and Q, which is the output. Time, time, bull, bull, right? We can also create insert, add row. We can also create this is the on time door. Okay, the door is off actually, not on. The door is off, T off time, which is also the same structure. And then the light is on timer. So we can say T time delay. So usually for timing, it is usually good to use T in front of it. It's just something that programmers have adopted. So here I'll put T here. T dot off delay, T on time delay. If you look at both of them, they are the same structure, right? But they are different data types inside the PLC. Same structure. Now, what can we do? Instead of using the global data type, which is what we have here, I can directly just drag the T off delay timer on this block to replace the global DB. I can directly drag the T time delay on this. And then our timers already point to the data block, our data block, rather than the global data block. So I can go ahead and delete this. I'll just click on delete, yes. And then I'll delete the other one as well. We don't need it anymore in our program. Instead of using the global data type, we directly use the data type in our block. We have an error here because this was pointing to the global data type that we just deleted. However, we don't need that anymore. We can just use the one in our block. So what we're looking at is the ET, elapsed time. So I can pick this and drag it here. And everything in our block should be fine. So what does it mean? It means we now have control inside our block to set everything we want to set. For example, this PT that we set hard coded, we cannot decide not to use the add code anymore because we have the DB. So what can we do? We can just pull in our PT here, and then we'll set it on the interface, which is our default value is what? T 10 seconds, right? So we'll set it on our DB. That's it. And same for the on delay. The PT, we can directly put it here. So it's not hard coded on the block. You can always change it in your DB, which makes it the better way to program. You don't need to go and start going into all your program looking for everywhere you did the add coding programs. You can directly go into your data block to see that. I'll compile, we'll download and see how this works. So it has to reinitialize the DB because we've changed the interface of our DB. So I expect it to reinitialize. It's compiling. You can see it has added the timers on our block. It would ask to reinitialize, of course. And then we said load it. Now we've made our program simpler. We've made it easier. Everything we're using is inside our block. We still have an add coded value here, right? I'll do that later. So let's go online to see how this works. If it works the way it worked earlier. So we're back online, right? The auto switch is on. I'll take it off just so we start from a clean state. I need to put the simulator on first. Now we have our simulator on, right? So the first thing is I'll put it in auto. Everything should go in the auto state. We have our outdoor sensor. We switch it on, which should open the door in this case. So the door is open. The outdoor sensor opens the door. And now Orange Man has gone inside the house, and then we switch off the outdoor sensor. Orange Man has now moved under the light, under this sensor, not the lights. The sensor is triggered. I'll trigger it separately. Let me put this on so you can monitor it from the DB. Since I cannot fit the simulation table, the program, everything into one block. Okay, so now, so you can directly monitor what I'm doing right on this DB interface. Now I'll switch on the indoor sensor. The indoor sensor, this sensor would come on, which is this, right? The indoor sensor is true now. So the 5 seconds on delay starts. Okay, it's run now. The light is on. The off delay has not started yet. So how do we trigger the door to close? Orange Man moves away from the sensor. So indoor sensor triggered off now. Indoor sensor will trigger off. The delay will start counting to 10. After 10, we compare. If it is 10, it's now almost 10. And then the door relay closes. So the door relay is now false. As you can see, the light is on. Everything is auto. Exactly how we want it. So it means our timers work perfectly when they were in the global block and when they were also in the instance block, which is what we set inside our DB. One more optimization that I want to do involves two things. I want to remove this from being purely hard-coded, right, into something that you can always program from the DB itself. So I'll use time, and what I want to do here is I want to program this to be 10 seconds, which is what we have there. And we'll name this, right? Uh, I'll just say T door delay. So that's the delay for the door. I will put this here directly. So instead of being hard coded, it should now appear on our DB. We can always change the time on the DB, which makes it easier. Another thing I want to do, you see we have two timers here, off, on. Imagine we have like 10 or 15 timers inside this same single block. We would then have a lot of timer here. So I want to introduce something to you, another data type, which is an array of any kind of data type. So here I will use T underscore orange timers. T orange timers. And what I want to use here is an array. So you have this data type, which means when you have the same data type that is occurring in many places inside your program, instead of having many of them, you can use an array. So here I want to use an array of 0 to 5, or you can start from 1 to 5. You can start from anywhere you want. So I want 1 to 5 of IEC timer, this. So all these timing types, they have different timing types. They have different timing data types. The ones that we have here are IEC timers. So now we'll see. These are created 1, 2, 3, 4, 5 because I said 1 to 5. If I say 1 to 20, 1 to 30, it will create 30 instances of this. And when you click on the drop down for each one, it's the same structure of what we have here. Same structure. Same. So I'll use the first one for our T, our door. I'll put the same thing I have here. And the second one, the second timer, I'll change it to T 5 seconds. The only problem with this is you cannot individually name them separately. You have to use the comment section now to name it. So now say this is the door off timer, and the second one is the light on timer, because they all have to take the name of whatever you use here. These two, we also don't need anymore because now I've put them in an array. We should get errors, of course. Now I can link these ones directly. I can pull this directly to the TOF delay. And the PT, I need to link the PT straight. This is the PT to this. I'll also link the on delay timer, this to this. On delay timer to this, and then the PT, which is now 5 seconds, to this. And don't forget, we were comparing our timing to the door delay, which is the first one, the off timer, to this. I'll link this to this. We shouldn't have any error in our block anymore. Now I hope you understand what I just did. So I created an array of timers, and now I can use this array of timers in my block as much as I want, which makes it easy. However, you have to name them properly. So whoever is seeing this would know what they are for. I'll compile this. Instead of having timer 1, timer 2, timer 3, timer whatever, 15, 20 timers, I've just put them in an array. Our DB should change again, and then it should ask us to reinitialize. You can see our interface has also already changed, or reinitialize. The block has changed to an array. Now everything will be downloaded into the PLC. We can already see our array of timers in here. We can see everything directly now on the interface of our DB. Looking good. We also see the timer com compare value that we set on our block, which is now 10 seconds, right? So I'll go online, and then we'll do our last check for this. So we're on auto. I'll take off the auto button just to put everything back to default state. Yes, auto is off. It's taking quite a while before my commands get to the PLC. Now I put auto back on. So you can monitor on this DB. I'm doing everything on the PLC sim version 20. I'm putting auto back to on right now. Let me save our project. Now auto is on. Our outdoor sensor, I put it on, and the outdoor sensor should trigger the door to open. Orange man is in the house. The outdoor sensor goes back off because the outdoor sensor can no longer see orange man, but the door stays open, right? Orange man passes through. And then we have the indoor sensor which goes on. The indoor sensor automatically then triggers the light relay, which takes 5 seconds based on the set time on the PT, switches on the light relay, the door stays open, and then when orange man leaves the indoor sensor, immediately orange man leaves the area of the sensor starts counting, compares itself to this value, which is 10 seconds in this case, and then triggers the door. And then the door relay goes off. So in this video, I've been able to show you how to use the on delay timer, off delay timer, how to use different timer data types, T on, T off, how to combine them in a set of arrays to get whatever programs that you want. Thank you very much and see you in the next video.